In this part of 9.2 day 3, we are going to be using completing the square to write equations of parabolas in standard form. Here we have our equations for parabolas. Now the first one here is one where it's opening up. That would be the one that's positive, or opening down. That would be our negative version. And then for the one that starts with x, it's opening left or right. If it's opening to the right, it's positive. If it's opening to the left, we know that it's negative. Now, sometimes we're not given an equation in this form. For example, this equation of a parabola is not in standard form, and we want to get it into standard form. So we want it to look like one of those two equations we had from before. How do you know which one? Well, since my x is squared here, I'm going to choose the equation where the x is squared, which is this one here. The reason why I chose this one is since my x is squared here, I know that it has to be inside the parentheses being squared, just like this equation. That's why I chose this specific one. I'm going to make it look like that by using what's called completing the square. In order to complete the square, I want to get the squared part of my equation and its like variable. In this case, it's the x squared and the negative 8x. I want to get those two on the same side and get everything else on the other side. Well, that means I need to get rid of this 13 here. I'm going to subtract 13 from both sides, and I'm going to have y minus 13 equals x squared minus 8x. My next step in this process is I'm going to add a number to both sides. Now, I could add whatever I want. I could add 5, I could add 32, I could add 47, whatever. It doesn't matter, because I'm keeping the equation equal on both sides. But I want to pick a very specific number, and the way I'm going to go about choosing that very specific number is by looking at this coefficient in front of the x. I want to get it into something that's factorable. So if I take this negative 8 here, and I divide it by 2, and square it, that's negative 4 squared, which is 16, and add that to both sides, I'm going to be able to factor the right-hand side, and it's going to be a perfect square. Now, what's nice about this is I can look back at this negative 4 here. That's what's going to go inside the parentheses being squared. So on the right-hand side, I'm going to have x minus 4 squared. You'll always use this number here inside of the parentheses. You'll always add this number here to both sides of the equation. On the left-hand side, we're going to combine like terms. We have y plus 3. Now, if you look at this equation, it looks almost identical to this one up here. I have my y minus k right here. That's my y plus 3. I have my x minus h in here. Now, I don't have anything out in front. Well, what is it? Well, when there's nothing out in front, I know that that is actually a 1. So you might ask yourself, well, if I was asked to graph this, how would I know what p is? Well, we need to solve for p if we want to graph this, because I'll have my vertex, I'll have p, and that will give me my focus and my directrix. If my coefficient here is 1, that's the same as 1 over 1. Well, I know right here I have 1 over 4p, so that's the same as 1 over 4p. Now I can solve for p. Some of you might already realize that, well, p is going to be 1/4. Well, we could also cross multiply, which we're all very comfortable with. So I have 1 times 4p, which is 4p. 1 times 1 is 1. Divide by 4, and I get p is 1 over 4, or 0.25. Either one's okay with me. And there you have it. The main thing it was asking for here is the equation written in standard form, which is right here. We went a step further and found p, so in case we needed to graph it, we're good to go.